ओके, रिकॉर्डिंग स्टार्ट हो गई है. आज है 2nd of Feb. Okay, so today we will going to study about the waves. And if I show you just give me a second, I'll show you the NEET syllabus, so you will get the idea. Basically, we have a few important topics under this chapter, waves. Let me mark them. First is the speed of traveling wave. You should know about it. Displacement relation is very important. Principle of superposition of waves is important because in this topic you are going to study about interference of waves, which is a very new but very basic concept. Okay, we should know very well about this topic. So I'm going to give you the entire lecture on this. Then I would say standing waves, organ pipes, and beats. These fundamental mode and harmonics all are going to conclude in organ pipes. So basically these few are the important topics of this chapter. Since this entire chapter is all about the mathematical interpretation, right? So I feel that's why it is quite tough for PCB students. But it is a myth. I mean, if you get the basic idea now, if you know basic formulas, you can understand this chapter. Okay. So what will I gonna do? I will divide this chapter into few sections. Okay. Number one would be basic, which we will going to do today. Okay. In this basic lecture, we will cover how to judge that whether this equation is an equation of wave or not, right? How to give that judgment. So we will study about the general equation of wave, and then we will talk about the phase. So these two are the hashtags of today's session. After it, we will go for principle of superposition. Okay. And it will followed by your interference of waves. And then we will go for standing waves. And then beats. Ideally, it's a lengthy chapter, but since it is very difficult chapter for the students, as per their feedback, so I would really want to start this chapter, and I don't know how many classes do we have and when we're gonna get through this chapter, but okay, let's try. So today, yeah. Whenever we talk about waves, whenever we talk about this thing, I think the only image which comes into our mind is this structure. In mathematics, we call it as a sine wave, right? This kind of structure comes to us. Yes or no?
Yes, ma'am.
Okay. Now the
Yes, ma'am.
question is, okay. See, it's fine. If you're getting this structure, this image, it's okay. It's cool. It's fine. ऐसा होना चाहिए, आना चाहिए. But in addition to this figure, you should remember few points also. जैसे कि you should know that waves are a disturbance. Okay, waves is basically a disturbance that travels through the medium. Okay, you can say कि wave is basically you could say कि क्या हो सकता है ये? It is a travel. You can say कि ma'am, energy travels. Right? Disturbance travels, or energy travels, or momentum travels. But be very sure about one thing, and that is particles do not travel. Okay, particles travel nahi karte. For an example, I gave you a string, a rope, and I tied its one end with the door, and I gave you the other end. You create a pulse, okay? So basically, you have created a disturbance. That disturbance travels through the rope now. Yes or no?
Yes, ma'am.
Exactly.
Yes, ma'am.
Do you feel ki a part of rope get detached itself from the entire rope and that moves through the end? Does that happen? ऐसे होता है क्या कि आपके रोप का द एंड दैट यू आर होल्डिंग, उसका कोई एक हिस्सा, एक पार्ट टूट कर आगे चला गया हो? ये सिर्फ एक डिस्टर्बेंस ही ट्रेवल करता है. आर यू इमेजिनिंग द सिचुएशन?
Disturbance travel.
Exactly. Only disturbance travels. Particle do not travel. So if particle is not traveling in this procedure, so what are they doing exactly? कर क्या रहे हैं वो फिर? If they are not moving, then what are they doing? So just remember this thing, that in this case, particles are executing simple harmonic motion. ठीक है? Or you can say कि particles are doing oscillations. Now, what are oscillations? I'll give you a brief hint about that. For example, this is the mean position. Or you can say where you're not creating a pulse or anything, then the rope is at stationary position. It is not moving at all. So that would be the mean position, a state of balance, right? Now you are giving it a pulse, you are giving it a disturbance, you are giving it a energy. So what will happen, that this particle moves from mean position to a positive extreme position, right? Then it comes back at this mean position, it will move further in the opposite direction and achieve negative extreme, then come back to this mean position. I would consider that this is the one cycle of oscillation. Yes or no?
Yes, ma'am.
So basically, this is what particles are doing at their own place. They are not moving in the space, but like they are not moving with the disturbance. What are they doing? They are moving from mean position to positive extreme, then positive extreme to mean to negative extreme to mean. So they are moving like this. Okay, wave is traveling in the forward direction and they are doing this kind of motion. Do we get the idea?
Yes, ma'am.
Okay. So we can say particles are doing SHM, or you can say कि particles are executing oscillations. Okay? Because we know कि oscillation is a broader term. Simple harmonic motion is a specific or a general case. Oh, sorry, a special case. Right? So we can say they are executing oscillations. Make sure that you remember all of these points. Okay? They will give you a complete description of the wave. So whenever somebody is going to ask you what is wave, make sure that this entire slide would be your answer. Is that fine?
Yes, ma'am. Yes, ma'am.
Now, if I change the basis of classification, you will get number of waves. Now you will get number of category of waves and number of categories it could be. For example, if you understand the previous slide, then you will get the idea that we have two types of motion that are involved in the wave. First is the wave ka disturbance, or you can say the wave's motion. The other motion here is particles motion, right? Because wave is moving in the forward direction and particles are executing SHM at their own place. So basically we have two types of motion, wave motion and particle motion. So on the basis of their direction, we can have two types of wave. Okay? I make this as my basis of classification. And then I can say that waves are of two types. And number one is longitudinal wave. Number one is longitudinal wave. Okay? In this kind of wave, the wave motion is parallel to the particles motion. Okay?
Yes, ma'am.
Okay. The other type of wave that we have is transverse wave. Okay? And in transverse wave, the wave motion is perpendicular to the particles motion. Okay? Is that fine?
Yes, ma'am.
Okay, you can remember it by this also, that this transverse, the T is actually looks like the this symbol, na perpendicular wala. So you can use it as a trick as well. If you forget ki, in longitudinal wave, is it parallel or perpendicular? So you can use this kind of trick. So basically, on the basis of its motion, we have two types of waves. Now, if I change the classification basis into requirement of medium for the propagation of waves, right? If I made it as my basis, then we have again two types of wave. Okay, we will have two types of wave. Can you tell me the names of that wave, if you know? Hmm? What are those two waves? Mechanical
Wow.
and non-mechanical. Okay.
Yes, ma'am.
Okay. Mechanical waves are those waves uh, uh, which require the medium. They require the medium for their propagation. Okay. For example, sound wave. Why I'm using this example? Because I will discuss the entire second half of this chapter for sound waves. Okay. When it comes to non-mechanical waves, so they are going to be the waves uh, who do not require medium for their propagation. Okay, which do not require medium. So we can say that they don't require the medium. And the example of these kind of waves is EM waves. Now let's consider an example. Let's say that this is the sun, this is the earth. Then the radiation from the sun is coming to our earth now, but there is no atmosphere, there is no medium. Then how is it going to be possible? So the possible explanation for this is that they are non-mechanical waves. They do not require medium for their propagation. And I'm telling you this one thing, they are EM waves. EM waves is basically what? That kind of waves in which a variable electric field produces the magnetic field, and in the resultant of this procedure, that variable magnetic field also produces the electric field. Okay? So this interplay of variability of electric and magnetic field generates the entire electromagnetic wave, and it reaches to the earth without any medium. Do we get this?
Yes, ma'am. Yes, ma'am.
Cool. So for time being, we will start our discussion with transverse wave first, and in the second of this chapter, we will study about the sound waves, or you can say the longitudinal waves. Okay? So we will start with transverse wave. Let's talk about the general equation of wave. Okay? General equation of wave. Now let me give you a scenario. For example, I give you a rope, I give you everything, and I ask you, can you tell me the displacement of some particle, or would some I just say, give me the expression for displacement. So what are the possible questions that you can ask to me? At least give me this much information so that I can give you the data of the displacement. क्या क्या क्वेश्चंस पूछ सकते हो आप मुझसे? I ask you to give me the displacement. ठीक है? So what are the possible questions that you should ask me first? सोचो. सोचो भाई.
What is the length of the rope?
Okay. Anything else? I think you should ask me na, ki at least give us the position of that one particle that you were interesting about, that you were interesting in. कि भाई हमको इस पार्टिकल का डिस्प्लेसमेंट चाहिए तो एटलीस्ट गिव मी द डिस्टेंस ऑफ दैट पार्टिकल ना, गिव मी द पोजीशन ऑफ दैट पार्टिकल. So at least I should mention this thing na, कि I want to know the displacement of this particle which is x distance away from the origin. So basically the displacement that I want is supposed to be a function of this x now, because every particle has different displacements at different instant. Yes or no?
Yes, ma'am.
Yes. So once I give you the location of that one particle, then what would be the other question that you should ask? See, if you're getting the lecture now, you will understand ki what are the possible questions that you should ask. Yeah, without which information you cannot give me the displacement of this particle. Think about it.
Ma'am, can you repeat?
I am asking you ki what is the displacement of a particle? So first question would be ki which particle? So I gave you the particle which is at x distance from the origin. Now you located that particle. What would be the next question that you should ask in order to give me the displacement? Or just the location would be sufficient? I gave you the location of that one particle. Can you find the displacement? Or you need something else? What is your take, basically?
Direction,
Anything else? What, Harshita, please come again.
distance.
No, I gave you the distance, na, x. That's why you look at that particle. I marked it as white one. See, when you go to that particle, you realize that it is always moving because it is executing oscillations. Now, it is moving from mean to positive extreme to mean to negative extreme to mean. So it is continuously changing its position. So you will ask, ki, okay, you localize this particle, but we need time instant as well. At which instant you want me to calculate the displacement now? So that's why you get the idea that this displacement depends upon two things: position of particle and the time instant. Do we get this?
Yes, ma'am.
Yes,
ma'am.
So the general expression or the basic mathematics would calculate that all the equations which have this kind of form, ax plus bt or minus bt, a and b are some constant, they are the function of x and t. This kind of function will be the equation of wave. Okay? This kind of function will be equation of wave. Is that okay?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now there is one more condition that I'm telling you. You should remember this one. That del f by del x, the second order derivative, sorry, here I should write t, is equals to v square del 2f by del t x2. This function is basically dependent upon two variables now, x and t. So can I do this kind of partial derivative? Huh? Do we know about partial derivative? Anyone?
No, ma'am.
Okay. Okay. Let me give you a hint first. See, if I tell you about a function which depends upon two variables or more than two, it could be 2, 3, 4, anything. Let's consider the x, y, z axis. Okay. So you can see कि a basic differentiation, a basic derivative is look like this, na, capital D or small d. We usually write like this, right?
Yes, ma'am.
Exactly. Now, can you observe this symbol? It is little bit tilted towards left, right? Okay.
Yes, ma'am.
So this symbol is known as partial derivative. Partial derivative. Okay. Now, if I gave you a function which depends upon three variables, x, y, and z, and I would ask you to calculate the rate of change, so basically you will go with differentiation. but it depends upon three variables. So what would we do in mathematics? We will consider two variables as constant while calculating the change with respect to one. For an example, I'm calculating the change of a function with respect to x. I will keep y and z as constants. When I will calculate the change of function, the rate of change of function with respect to y, I will keep x and z as constant. Similarly, when I will calculate the rate of change of function with respect to z, I will keep x and y as constant. So basically, we are doing a partiality with other two variables now, as their basic nature is of that they are variables, but I'm treating them as constants. So it is some kind of partiality you can understand in a layman language as well in this way. Okay? I will give you a mathematical explanation for that. I hope you will understand by that example. So let's consider an example that a function a function, let's say f. It expressed as 2x square y, 2xy square, and it could be yz cube and xyz. Okay, this is the function. Now I said कि भाई this function depends upon three variable x, y, and z. Calculate the rate of change of this function. Okay. So what will you do? You first calculate rate of change of this function with respect to x, but you keep y and z as constant. So this kind of mathematical, representation is explaining us that we are calculating rate of change of function with respect to x, keeping y and z constant. Okay?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is very simple. You will consider y and z as constant while calculating the differentiation. Okay? So here you can see we have 2x square y first. 2 and y, both are constants. Just differentiate x square. So it would become 2x plus. Consider 2 and y as constant. Just differentiate for x. It would become 1. Again, y, z, both are constant. Write them exactly like this. Here, x is variable, y and z is constant. Keep y and z exactly same and just put x as well. Okay? So we will just perform the differentiation for x only, keeping other variables as constant. For example, if I want to calculate the rate of change of function with respect to y, keeping x and z as constant, I would write 2x square is constant and y would be 1. Similarly, 2x constant, y square would be 2y, and y is constant, sorry, z cube is constant, and it would be 1 plus x and z is constant, and at the place of y, you can differentiate it and you will get 1. Can you find the expression for del f over del z, keeping x and y constant? Can you do this?
Yes, ma'am.
Yes, please. Okay, do it and let me know. Yes, guys, could you please share your answer? Gayatri, do you want to share your answer, beta?
Yes, ma'am.
हाँ बताओ.
2x square y
Hmm.
plus 2xy square plus y 3z cube 3z square plus
Yes,
x plus xy.
very nice. Do we all get the same answer?
Yes, ma'am. I put the last one.
Cool, cool, yes. So this is what partial derivative is. ठीक है? Similarly, यहाँ पे मैं लिख देती हूँ, this is the extra slide where we understand कि what is partial derivative.
Ma'am, can you repeat?
Beta, where you got stuck?
Ma'am, I haven't understood.
See, it's very simple. I said if a function depends upon three variables or two variables or more than two variables, and I want you to calculate the change, rate of change of that function with respect to all these variables. So what would you do? First, you will differentiate that function with respect to one variable, keeping other variables as constant. So basically, they are not constant now, but we are doing a partiality. We will consider them constant and differentiate the entire term with that one, with respect to that one variable. For an example, here this function depends upon x, y, and z, and I calculate rate of change of function with respect to x, keeping y, z constant. So wherever in the expression you got y, z, treat them as constant. Like you do, you do a simple differentiation with 2, 3, 4, and any other constant. Keep them as constants, right?
Okay, ma'am.
Okay. Okay. So you should remember this equation here. I said that displacement depends upon two variables, position of the particle and the time, right? So double differentiation of this y with respect to t is equals to some constant. I will talk about this constant later on. Multiplied by double differentiation of y with respect to x. Okay? This is partial derivative, partial differentiation. This constant now v ka square, this v is the speed of wave. We will talk about it in further. Okay? We will talk about it in the further slides. Filal, just mark it as the speed of wave. Is that okay?
Yes, ma'am. Yes, ma'am.
Okay. So on the basis of this expression, let me mark them. So on the basis of this expression, this function, and this. So basically, these three things would give me a format of the equation. Of equation, basically, now our discussion is to calculate general equation of wave. So we get an idea that the standard form of a wave looks like this. It could be plus, it could be minus, okay? Anything can be happen. But this kind of equation is our journal equation of wave. Is that okay?
Yes, ma'am. Yes, ma'am.
Okay. Okay. Let me tell you ki, which variable means stands with what thing. For example, this y is the displacement of particle at any instant. Okay? Displacement of the particle at any instant. Fine. This A, it is the maximum displacement. Okay? You know, whatever this entire thing in this bracket, okay? Whatever this entire thing in the bracket of sign, we will call it as a phase. We will call it as phase. Okay? Can you see the symbol phi? Huh?
Yes, ma'am.
This phi is known as the initial phase. Okay, this is known as the initial phase, or you can say ki, phase at t is equals to 0. Now let's focus on few other things. For example, this omega. This omega is 2 pi by t. This k is 2 pi by lambda. Okay? Will you remember it?
Yes, ma'am.
Okay. Now there is one more thing, and please keep it in your mind that if you get this negative sign, if the coefficient of x is negative, okay? Negative x basically represent that a wave is traveling in positive x. That wave is traveling in positive x-axis. Okay? Positive x in the expression represent that wave is traveling in negative x-axis. Okay? it is opposite, but please make sure that you will remember it. The negative x in the expression represent the wave is traveling in positive x direction. If it is positive, it means waves is traveling in negative x. Cool?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. चलिए. Let's talk about the speed of wave. Okay? Let's talk about the speed of wave. Okay. Basically, I tell you that we have two types of motion, na? Particles motion as well as waves motion. So when it comes to speed of wave, then you have a very simple formula that speed of wave is equals to coefficient of t upon coefficient of x. As you can see in this expression, the coefficient of t is omega and the coefficient of x is k. So you can write it is omega by k, right? And this is something which is not, just a formula. It is a very basic concept. Let me explain you one thing. Can you see this omega? We can write omega as 2 pi by t now. This k can be
Yes,
written
ma'am.
as 2 pi by lambda now. 2 pi will get cancelled out. And you will leave with lambda by t. Lambda is what? It is wavelength, the distance traveled by a complete wave in time period. And this t is time period. So basically, this is distance upon time. It has to be the velocity, na?
Yes, ma'am.
Right? Just it's very basic. You should remember this formula. When it comes to calculate the speed of a particle, speed of a particle, कैसे करें इसे? How do we calculate the speed of a particle? I guess I gave you an equation of wave which talks about the displacement of particle. If it is the displacement of particle, you can either you can write at phi or not. It's just a constant, so it will not make a lot of difference in this calculation. So you can ignore it. Okay? For timing, if they gave you some initial phase, then please consider it. Okay? For timing, let's say y is equals to a sine omega t minus kx is some wave that I gave you, and I want you to calculate the speed of particle. But if you have displacement, so you can calculate velocity. Na? Just differentiate it. Yes or no? Say something.
Yes, ma'am.
Okay. Can you calculate the acceleration of the particle? Hmm? Differentiate velocity for the respect to time. Come on,
Yes, ma'am.
with the expression. Tell me the answer, Victor. Share it. बताओ भाई, it's very simple ना, you should do it. Can't you differentiate this expression? I would not encourage this kind of behavior in the class. It's very simple. Just differentiate it with respect to time. Omega is constant, A is constant, keep it exactly. Differentiate cost with respect to time, you will get sine with the negatives, right? It would be omega t minus kx. Since you are differentiating this equation with respect to time, so you have to add this omega, multiplied entire expression by omega. Can you see this? A sine omega t minus kx. It is your y. So basically you will get acceleration as minus omega square y. And it has to happen like this because waves, these particles are executing, oscillation. And this is the condition of oscillation. At least at this point of time, I can expect this much calculation from you. Here, just do a question here. I gave you an expression for y. It can be your solve this question and give me the answer. It is 18:30 right now. You have exactly 1 minute to solve this question. क्या आंसर आया बेटा? आंसर क्या आया? आप आज आंसर नहीं बताओगे तो ये क्लास इसके आगे नहीं चलेगी, ठीक है? अगर आपको समझ में नहीं आया है तो आप पूछो ना.
Not able to solve, ma'am.
हाँ,
Not able to solve.
why? That's the point. अगर आपको पिछली स्लाइड समझ में नहीं आई है तो आपने अलाउ क्यों किया आगे जाने के लिए? ये क्वेश्चन एक लाइन का नहीं है. Do you get this slide or not?
No, ma'am.
स्पीड ऑफ वेव इज बेसिकली कोफिशिएंट ऑफ टी अपॉन कोफिशिएंट ऑफ एक्स। आपके पास ये जो इक्वेशन है इसमें टी का कोफिशिएंट ओमेगा है, एक्स का कोफिशिएंट के है, आप ओमेगा बाई के कर दो, यू विल गेट द स्पीड ऑफ वेव। बस यही फॉर्मूला है। अगर स्पीड ऑफ पार्टिकल निकालना है तो आपको डिस्प्लेसमेंट दे रखा है पार्टिकल का, आप उसे पता है जब डिस्प्लेसमेंट होता है उसे टाइम के साथ अगर हम डिफरेंशिएट करें तो वेलोसिटी मिलती है, वेलोसिटी को टाइम के साथ डिफरेंशिएट करें तो एक्सेलरेशन मिलता है। बस ध्यान रखोगे ये पार्टिकल का इक्वेशन है, वेव का इससे कोई लेना देना नहीं है। और वेव की स्पीड निकालने के लिए फॉर्मूला है टी की कोफिशिएंट को एक्स की कोफिशिएंट से डिवाइड कर दो, बस।
मैम आई गेट द 3।
हाँ, अभी समझ में आ गया?
मैम आई गेट द 3। यस मैम।
ओके मिश्रा, आपका आंसर है तो बेटा आपने बताया क्यों नहीं? भाई तुम ऐसे मत करो, इस इक्वेशन को सिंपल आप कंपेयर करो ना गिवन इक्वेशन से, सॉरी स्टैंडर्ड वाली इक्वेशन से। जब आप कंपेयर करोगे तो आपको समझ में आएगा कि इस इक्वेशन में एम्पलीट्यूड 0.025 है, इस इक्वेशन में ओमेगा आपका टी का कोफिशिएंट 1.5 है, और इस इक्वेशन में के 0.5 है। तो अगर मुझे स्पीड ऑफ वेव चाहिए,
आंसर इज 3 मैम।
यस, ओमेगा बाई के, ओमेगा का वैल्यू 1.5, जिसको आप 3/2 लिख सकते हो, 0.5 इज 1/2। बताओ, इज इट ओके ना?
यस मैम। यस मैम।
आगे से जो भी स्लाइड समझ में ना आए उससे आगे बढ़ने नहीं देना है, ये बात याद रखो, क्योंकि मुझे 3 स्लाइड बाद वैसे भी पता चल जाएगा कि तुम्हें समझ नहीं आया है। तो क्यों ही बेकार में अपना और दूसरे का मतलब क्लास का टाइम वेस्ट करना। अगर नहीं समझ में आया है तो मेक श्योर करो कि आप जब भी पूछ लो, फिर ये चैप्टर है नहीं टफ, पर ऐसे करोगे तो फिर टफ रह जाएगा। चलो अब बात करते हैं फेस की। बेटा फेस मैथमेटिक्स का एक ऐसा टूल है जो हमें दो बातों के बारे में बताता है। फेस इज अ मैथमेटिकल टूल which helps us to find two things. Number one is position, ठीक है, position of particle. Number two would be direction of motion. Okay, now let's explain why do we need this phase, why do we need to know direction of motion, and how this phase can do both the functions. ठीक है, so for an example, let's go with that simple pendulum. This is the mean position, right? It will
Yes
move from mean to positive extreme, then positive extreme to mean, then mean to negative extreme, and then returns at negative mean. ठीक है, this is the complete cycle. For an example, you can see that this object repeats this particular position twice. Yes or no? इस ऑब्जेक्ट
yes
ने
मैम।
पोजीशन 2 बार रिपीट करी है, and every time it has different direction of motion. पहला सिचुएशन में it is moving towards extreme position, and in other situation it is moving towards mean position. So if I gave you this position, how will you define where it is moving? Is it moving towards positive extreme or is it moving towards mean? How do we get the idea of that thing? So phase will help us. ठीक है, समझ में आया फेस का काम क्या है?
यस
एक
यस मैम।
को पार्टिकल 2 बार रिपीट कर रहा है, तो वो चीज है कैसे, आई कैसे, मतलब वो चीज पे जो बॉब है वो पॉजिटिव एक्सट्रीम की तरफ जा रहा है कि मीन की तरफ जा रहा है, ये हमको कैसे पता चलेगा? ये हमको फेज बताएगा। अब देखते हैं कैसे बताएगा। ये वेव दिखती है ना हमको, this is 0 degree, right? This is 90 degree. Just consider sine wave. This is 180 degree. It is your 270 degree. It is 360 degree. इतना सही है? Is it fine?
Yes, ma'am.
Okay. Now consider the rope here. वो rope consider करो. ये जो 0 डिग्री है, यही तो मेन पोजीशन है जहां पार्टिकल इनिशियली था. A state of balance. Yes or no?
Yes, ma'am.
Okay. So you can say कि 0 degree is your mean position. As particle is moving towards 90 degree, its displacement is continuously increasing and it would become maximum at 90 degree. Yes or no?
Yes, ma'am.
So you can say that this is your positive extreme. Now, when object is moving from 90 degree to 180 degree, continuously its displacement kept on decreasing, and at 180 degree, it again comes at mean position. Yes or no?
Yes, ma'am.
Okay. As object moves from 180 to 270, continuously its amplitude is increasing but in opposite direction. Amplitude तो अभी भी बढ़ रहा है, लेकिन opposite direction में. So at 270 degree it is maximum in opposite direction. 270 degree पे maximum हो गया है, opposite direction में you can say कि it is negative extreme.
Negative extreme.
Yes. Again, when object is moving from 270 degree to 360 degree, it kept on decreasing और कम होते होते वापस मीन पर आ गया. Right?
Yes, ma'am. Yes,
तो
ma'am.
ध्यान से देखो, हमने एक ही ग्राफ पे एंगल्स भी लगा दिए और पोजीशंस भी लगा दी. If you observe this wave carefully, you will get the idea that we have overlapped positions and angles all together in a wave. Somehow, I associate mean position with 0 degree, positive extreme with 90 degree, again mean position with 180 degree, negative extreme with 270 degree, and again mean at 360 degree. As you can see that in oscillation as well, this mean position is crossed thrice. One, when it is moving towards positive extreme, second when it is coming from positive extreme, and third when it is coming from negative extreme. तो 3 बार ही मीन पोजीशन को क्रॉस कर रहा था पार्टिकल और 3 बार ही आपको मीन पोजीशन देखने भी मिली, 0 डिग्री, 180 डिग्री एंड 360 डिग्री. डू वी गेट दिस?
Yes, ma'am.
तो अभी अगर मैं आपको कोई सेम पोजीशन दूं और मैं बोलूं कि फेस 45 डिग्री है, तो आपको पता है कि 0 से 90 डिग्री के बीच में इट मींस ऑब्जेक्ट मीन से पॉजिटिव एक्सट्रीम के बीच में होगा. यस और नो?
Yes, ma'am.
If I give you the angle 135 degree, you will say कि the angle is lying in between 180 degree and 90 degree, which means positive extreme to mean. It means object is moving from positive extreme towards the mean position, right? And 45 degree, 135 degree represent the same position. 45 degree and 135 degree are at the same position. लेकिन डायरेक्शन ऑफ मोशन अब आप पहचान पा रहे हो. जब 45 डिग्री है तो मीन से पॉजिटिव एक्सट्रीम जा रहा है. क्यों? क्योंकि 0 से 90 डिग्री के बीच एंगल लाई कर रहा है. और जब आपका 135 डिग्री है तो वो 90 डिग्री से 180 के बीच लाई कर रहा है. इसका मतलब पॉजिटिव एक्सट्रीम से मीन पर आ रहा है. डू वी गेट दिस?
Yes, ma'am.
ओके. एक बारी इसको हम सर्कुलर मोशन पर भी देख लेते हैं, एक सर्कल पे भी देख लेते हैं. लेट्स ड्रॉ अ सर्कल फॉर इट एंड अंडरस्टैंड द सेम एग्जैक्ट थिंग. ओके. दिस इज योर मीन पोजीशन. अगर ये पार्टिकल है तो देखो ये इसका डिस्प्लेसमेंट है. दिस इज द डिस्प्लेसमेंट. दिस इज द पोजीशन ऑफ पार्टिकल. दिस इज द डिस्प्लेसमेंट. Displacement kept on increasing now and it got maximum at positive extreme. Again it is decreasing and it will become 0 when it achieve the mean position. Again it is increasing but in the opposite direction and will achieve the highest or the negative extreme, you can say. Again it keeps on decreasing and again it will come back to mean, right?
Yes, ma'am.
Again this is 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. So basically you can say that if a particle is in between 0 to 90 degree, then it is moving from mean to positive extreme. And angle will lie from 0 degree to 90 degree, right? Because at
Yes,
0
ma'am.
degree, it is exactly at mean position. At 90 degree, it is exactly at positive extreme. In between this range, it is moving from mean to positive extreme. Similarly, when it comes into this quadrant, so you would say the angle would be from 90 degree to 180 degree, and particle is moving from positive extreme to mean. In this portion, you can say the angle lies in between 180 degree to 270 degree, and particle is moving from mean position to negative extreme, right? Similarly, here you can say the particle is moving in between 270 degree to 360 degree, and the direction of motion would be negative extreme to mean. Do we get this?
Yes, ma'am.
Okay.
Yes, ma'am.
Basically, this is the best explanation about the phase I can see anywhere, around YouTube or somewhere else. I feel it completes the phase entirely. It will give you the entire feel of phase, and also it defines how it phases, performing its both function, that it is defining position as well as the direction of motion. So that's it. For today's session, we will keep it till this point of time. In next lecture, I will tell you more about phase difference. Okay. And then we will talk about principle of superposition, which includes interference of waves. So this would be your second lecture. Okay. Make sure one thing, that you will revise basic formulas, basic format of trigonometry. Okay. The basic mathematics. And if you don't know how to do that, ye kitna karna hai, so let me help you. You know na that bit.ly sheet that I gave you, bit.ly/Khushi ma'am? Huh?
Yes, ma'am.
Okay.
Yes, ma'am.
Click on this one. Go in class 11th wala tab. Go for basic mathematics. That is first chapter that I taught in this portion, in this section, in this session, mathematics. And go for trigonometry. सिर्फ एक lecture है trigonometry का, I guess. Just completed. Okay. So thank you so much for being so nice. It really means a lot. And please remember one thing, that I would really appreciate if you tell me, ki, ma'am, I'm not getting this slide, I'm not getting this point. Please repeat. I would love to hear it. Okay? And I will never mind ki agar aap mujhse baar baar pooch lo, I would appreciate it. So please do ask. And have a nice time ahead. And don't mind. Okay? Whatever yeah, thank you. Bye. Have a nice time.
Thank you, ma'am.
Welcome. Bye bye.